Hello everyone, and thank you for joining today's webinar for the MSc in Computer Science degree for Heriot-Watt University in partnership with Coursera. My name's Matthew and I'm a Senior Enrolment Representative. Joining me today, we have my wonderful colleagues from Coursera, Pedro Suarez and Hage, who are monitoring the live chat for your questions, and they'll be helping behind the scenes. We'll be starting off today with a program overview, followed by an admissions requirement and tuition fee update. Then the most important part of today's webinar, which is why program matters, with a member of the faculty. Jurriaan, if you'd like to come on on screen as you are and introduce yourself.
Yes, hello. So my name is Jurriaan Hage. I'm a professor of computer science, also head of the Department of Computer Science at Heriot-Watt University, and also Deputy Executive Dean. And I also accidentally designed the program that I hope you will all be joining. Happy to talk to you later.
Thank you. As the presentation goes, feel free to type any questions you have into the Q&A box, and there will be a recording of the webinar, which will be shared with all attendees afterwards. So let's get started. As mentioned earlier, we have a special guest joining, but we will follow more of that later. So the program overview. So let's start with some insights into Heriot-Watt. So it's a specialist pioneering university. It's #1 in Scotland for AI, with a global presence. It's world-renowned in innovative research and a highly employable graduate program and masters. As a matter of fact, Heriot-Watt University is the highest ranked university in Scotland and the second in the UK for graduate outcomes in the Graduate Outcome Survey of 2024. And when students enroll in Heriot-Watt University in the MSc Computer Science, they're joining a global community with 27,000 other current students and more than 160,000 alumni across 190 countries. As the first university in Scotland to offer a computer science degree, and now home to the UK's National Robotorium, Heriot-Watt is globally recognised for its expertise in robotics and computer science. Overall, 88% of the research output coming out of Heriot-Watt has been classified as world-leading and internationally excellent from the Research and Excellence Framework of 2021. And with this programme, you'll be learning from globally recognised technology experts while not having to leave your home or your workplace, which is incredible. So, career prospects are at the forefront of many students looking to pursue further education. So you might be interested to hear that over 15% of the university students have transitioned into CEO or managing director roles, the highest percentage found anywhere in the UK. Specifically designed to get you into industry ready, this MSc combines fundamental computer science and mathematical learning with practical skills in programming, AI, machine learning, and database management. You'll be fully prepared to reshape your career using the world's most exciting new technologies, even if you don't have a background in computer science. After graduation, your skills will be in high demand across many industries, preparing you for a range of diverse job roles, including full stack developer, cloud architect, DevOps, engineering, and data science. So with guidance from renowned academics who are experts in their field, you'll be critically engaged with your Coursera material and discuss how to apply the real world changes. Your program director will be Abra Ula, who has over 20 years of experience in both industry and academia. You can also see on the slide other leading academics who will be supporting you on your educational journey. Here we would like to share with you insights from Professor Sarah Lombardo, who's the Executive Dean of the School of Mathematics and Computer Science at Heriot-Watt University. I'll give you a few seconds to read this quote. Notice how Professor Lombardi highlights that computer science is far more than just writing code or thinking up complex algorithms. It's more about using technology to improve lives, innovate, and create positive impact. This brings me to the next slide, where we'll be exploring a deeper meaning into how to understand the program and the structure. So let's talk about what you can expect from the program and how you'll be studying. This fully online program has been designed to provide a flexible learning experience allowing you to acquire the skills and knowledge without having to take a career break and fitting your studies around existing commitments. The degree can be completed in just 2 years or take up to 8 years to finish. The overall duration will depend on how many modules you take each semester and your time commitment. We recommend that you spend between 16 to 18 hours per week per course, and this will increase should you register for more modules, something to keep in mind. The degree consists of 8 courses plus a final project. 7 of the courses are worth 20 credits each. You will also study towards a professional certificate worth 10 credits and complete a final project worth 30 credits. Each course is studied over a 12-week period. The content of the programs and courses is reviewed annually to make sure it is up to date and relevant. All of these courses are designed and delivered by academics from Heriot-Watt University, meaning students will benefit from the same level of academic excellence as the university's on-campus students. What typically a day might look like for you is that you'll log on to Coursera and you'll see the course you've registered for on the dashboard, and you'll notice that this is programmed and runs using a blend of pre-recorded video content, written study material, optional live sessions. Courses include supplementary reading, pre-recorded video lectures, assignments, and discussion forums to help you spark connections and build networks with your peers. These will also involve 3 webinars per course per semester, and we'd advise learners to attend so that they can benefit from learning and from the community. The live sessions will be held twice to accommodate time zones, but don't worry if you can't attend, as they'll be recorded and you can watch them back later. The final online assessment normally takes place at the end of the cohort. They're online and run over a period of 2 weeks. To pass, you will need to reach grades D or above. Students may be allowed 1 initial attempt and 1 resit for each course, with a maximum of 3 resits permitted across the program. Let's now move on to review the admissions requirements. So there are 2 admissions routes, standard and performance-based pathways. One of the unique positions of this program is that the admissions to the program doesn't depend on your educational or professional background. This is where the performance-based admission pathway comes in, which lets you showcase your ability to learn rather than your credentials. To qualify for the performance-based admissions pathway, you'll need to complete 1 course from the programming and programming design starting in May. You can also secure a place in the computer science by applying through the traditional application-based route, which we call the standard admissions pathway. If you are applying via the standard route, you will need to have an undergraduate degree in a STEM-related subject and the ability to meet the English language requirements. So the tuition fees. The total indicative cost for the MSc in computer science degree is £8,995. This program is available on a pay-as-you-learn tuition model, which each taught course is £1,285. The tuition fee includes any study materials required and assessments. You can pay per course to help you spread the cost of the program over your studies. You'll also earn a globally recognized professional certificate from a leading tech company such as IBM, Google at no additional cost. There is also no application fee to apply. Please note that the tuition fee listed of courses starting in 2025 and the indicative full program fee listed does not take into account any annual fee increases which normally occur annually. Whilst there are no scholarship options available, students often explore possibilities of employer tuition reimbursement. Students who previously studied at Heriot-Watt could be eligible for a 20% tuition fee discount on their postgraduate program. Unfortunately, this degree is not eligible for the FAFSA loans. Now let's review the application checklist. So to apply for the standard pathway, you'll need a first or second class undergraduate degree in a STEM-related subject, provided as an academic transcript from a university, with an English translation if necessary. You'll also need to be above the age of 18 to apply. If you've declared that English isn't your first language, you'll need to confirm your ability to meet English language requirements. The minimum English language requirements for entry for this program is an IELTS grade 6 completed within the last 2 years, but other tests may be accepted too. If you're considering to apply via the performance-based route, all you'll need to provide is a concise and persuasive supporting statement outlining why you want to enroll in this program and your professional or academic ambitions. The statement should be between 500 and 1,000 words. If English is your first language, you must demonstrate the required level of proficiency in your supporting statement. Formal language tests are not mandatory. So to help you to apply for the correct program and via the appropriate admissions pathway, I would like to share some screenshots to guide you through the application process. When you start your application via the Heriot-Watt portal, you will first need to create an account. Please make sure that you select the correct year, online distance learning under the location, and select postgraduate taught under the academic level. For those eager to start working on the applications, they are now open. Once you've set up an account, you'll need to create a new application. Please make sure you select the Heriot-Watt Online Distance Learning Postgraduate options as shown on this slide. And this will then allow you to select the appropriate admissions pathway, standard or performance-based. Please select the most appropriate study option, as this application process will look a bit different depending on the route. Once you've submitted your application, please remember to attach the required documents such as your personal statement, degree certificate, or English tests. Your application is now complete and won't be reviewed until all the required documents are provided. You'll see on your application homepage, action required under the status as shown on the slides. Please make sure you click on view to provide anything outstanding. Once you've submitted and completed your application through the Heriot-Watt online portal, you'll receive an email confirming that your application has been received. The admissions committee will review your application. It can take up to 7 business days for the university to make a decision. However, this is dependent on successful completion and correct documentation being submitted. With your application, therefore, I'd strongly recommend uploading any of your documents, such as transcripts, personal statements, or English language requirements, on the application portal, as missing documents will lead to a delay in response. Once your application has been reviewed, you'll receive either a conditional or unconditional offer or admission onto the program. You'll see an update on your application email where you need to log into the application portal to view your decision letter. Do check your spam folder just in case. Please note that if you have a conditional offer, you'll be required to provide further evidence in order to change this to unconditional, and please refer to the offer letter for further details. If you receive an unconditional offer, you'll have to formally accept this through the online application portal. Once you've officially accepted your offer, you will need to complete your enrolment and registration for your first course by processing the payment. Once the payment has been made successfully, you'll see the course on your student profile. Completing the registration early will allow you to have a head start on your onboarding courses. Close to the start of the semester, you'll receive an email invitation with instructions to link your Coursera account. You'll also receive an announcement as soon as access to your registered courses and the orientation modules become available. Once you've completed all of these steps, you'll be starting the courses on the 8th of September 2025. And now I will hand over.
Thank you. Next slide, please. Next slide, please. So the plan I have for today is I will say a little bit about myself, although I've already kind of revealed some details. Then I'll talk about the program, and some of these details will be familiar from what was just told. But I will give some additional details about particular courses, for example, that we'll be teaching. Then I will talk about the aspect why programming matters, and that is kind of visible here in point number 3, where I kind of suggest that programming is yet another basic skill that we think everybody may want to be proficient at. And I will link that up with the various courses that we have in our program and where you will be taught what. And at the very end, there will be ample time for questions. So don't worry about doing that. If you have any questions, I think you put them in the chat and we can look at them later. Next slide, please. So I already talked a little bit about myself. I'm the head of the Department of Computer Science. I've been that for 3.5 years now. I'm originally from the Netherlands. This is a screenshot from my website that explains a bit about me. You can find me online. You can find me on LinkedIn if you want to. I'm also the Deputy Executive Dean of Max. But I think one of the reasons I'm here particularly is because I also helped design this program. Next slide, please. So what is generally the way I view the program? It's a master in computer science that we teach at Heriot-Watt University, and it's a collaboration with Coursera. So everything happens within the Coursera platform. It's a 2-year master program. And if you look at what kind of people are we targeting, I think there are people that have a bachelor with a related but still slightly different area. It could be economics, it could be biology, it could be all kinds of things, but not specifically computer science or AI. Or some people that have moved into a job that involves a lot of ICT or computer science, and they have basically garnered the skills to deal with the technologies, but they've never had a formal training in computer science. And that can hinder them, I think. So for these groups of people, that we have designed this particular program. So our intention is to upskill people, and I would even say it's like up transferable skill, because many of the things we'll be teaching you in the program are not particular technologies, and then you would only know and understand these technologies, but also giving you the concepts that underlie those technologies, so that if new technologies arise, and remember, we are working in computer science, the face of computer science changes about every 5 to 10 years. Technologies that are popular now might not be available 10 years from now, or only very limitedly, and new technologies will have arisen. So the focus, I think that's a general theme that kind of runs through our entire offering, both on campus, but also within Coursera, is that we are interested in learning people how to teach themselves computer science. And we do that, of course, by teaching you computer science. We've discussed direct and performance-based admission, so I think we can move on to the next slide now. So what we do is we've kind of broken up the program into 2 pieces. We start with 4 core courses that I think any computer scientist should understand and know, and they form the basis of that conceptual understanding what computer science is all about. This is programming and program design, logic and discrete math, so that is the mathematics that is relevant to computer scientists, as it were, databases and algorithms. This is followed by 3 more specialized courses where we kind of move into a particular domain within computer science. The first of these is called software engineering. So software engineering is the challenge of not writing programs, but writing applications and building systems. So there's a lot more to do. I mean, it involves programming, but programming is only a very basic skill that allows you to go into software engineering. But software engineering is also about building big pieces of software that need to live for very long, that you design with people in different countries over a long period of time. So programming, software development tends to be more a social problem than maybe a technical problem. Then we have 2 additional courses, one on AI and one on machine learning, that kind of try to bring you up to speed in what is, for many people, a big reason to want to study computer science in the first place, because it is where artificial intelligence and machine learning have arisen. And these, of course, are things that are very much in demand in the industry, and also of just general interest to people. Now, finally, when you've learned all this, you will be doing industrial course, which will kind of help you, show you that you can actually teach yourself new things without us being involved, right? Because in the end, later on, when you have your degree, you move into industry, you will be expected by any company that you work at to maybe learn a new technology and do that independently. So that is our focus, to kind of give you that firm understanding, this foundational knowledge of what computer science is all about, so that you can do that. And then the final one is the capstone project, where you do a project, maybe in any company that you might already be working in, or maybe when you're maybe sitting at home and you just have a lot of time on your hands, you can do a project of your own. So there's no restrictions or limitations or assumptions we are making about the capstone project. But the capstone project is intended to kind of put together all these different pieces from the various courses you have done and do a standalone independent project, and bring that to completion. Next slide, please. So what do we provide? Well, the goal here is that we provide accessible teaching materials, lecture notes, and engaging videos on the Coursera platform. We make no assumptions about how much time you spend on a weekly basis or during the semester. You decide when you want to study on the materials. There will be some synchronous moments, particularly the synchronous virtual office hours, which take place more or less once a week, which may also, for example, it's for answering questions, it's for talking with academics, but it also may, for example, include live coding demonstration, depending on what the teacher, the academic, likes to do. And this is for every course on a weekly basis. And on top of that, there are 3 synchronous recorded community building webinars, where the first webinar typically looks at introducing the course. What is this for? What will you learn? The second webinar tends to be about, okay, let's say you've completed this course. What would you look at then? And what is beyond what we are teaching you? Because we certainly cannot teach you everything there is to know. And then finally, the third one is just before the exam, where we give a revision webinar. So as part of our offering, there is formative assessments on the Coursera platform and sometimes outside of the Coursera platform, all kinds of labs, tutorials you can do and follow to build your knowledge, and upon completion, hopefully for everybody, a master's diploma. Next slide, please. However, so one of the things that we assume is that when people come into this program, they want to learn, they want to develop, right? You are in charge of your learning. We are there to help you, assist you, provide materials. But I think a program like this is only worth something if you really work at it. So don't think about what it takes to pass the exam. Try to make the most of learning the most while we can help you doing that learning. And this is particularly true for programming. Programming is an activity like riding a bicycle. It's not something that I can give you the rules for and then you know how to work it. No, it's something that takes a lot of time, a lot of experience, trying things out, failing, falling down, and getting back up again. Then that expertise will come, but it takes effort. But what is programming exactly? So let's go to the next slide. So what I want to talk about, particularly when we talk about programming, is about programming and to kind of contrast it with other kinds of terms that you sometimes hear mentioned when people talk about programming, which is, for example, computational thinking or analytical skills or abstraction facilities. So I want to talk about these notions and how they, in my mind, relate. And also discuss then, why is it important to know how to program as a computer scientist? In our program, we start you off with Java, although there are other languages that you can encounter later on, like Python and SQL in the course, but we start off with Java. Why did we choose that? Is that relevant or not? And then finally have something to say about Gen AI. Next slide. So what is programming? Or a lot of people call it coding. For me, it is mapping a process or a stepwise algorithm to a programming language, like Java, like C#, any language will do. Sometimes these languages are even visual and they're not textual. I'll have an example of that in a minute. So it assumes you have some kind of stepwise solution already in your head. You've conceptualized it already. And programming or coding allows you to run that idea on a machine, on a computer, to execute it, instead of that you have to run the program in your head, which that would be quite inconvenient. So when people talk about problem solving and not just programming, it typically means that you first have to come up with a solution. So somebody gives you a problem, you have to design a solution in your head that is problem solving. And then you will take that idea, that solution, and turn that into a program that can run on a computer. That is programming. So they're like 2 different steps. But if you go to a larger scale, and I already suggested that earlier when I talked about the software engineering course, right? Programming is not just about writing small things that run on your computer. At some point, when you go into industry expects you to build big systems. So a lot of the problem solving is actually not that relevant anymore. It's more about, how do I organize big systems effectively with lots of people being involved, with lots of stakeholders that I need to negotiate with? How do I do that well? And that's actually where also programming comes in a little bit, because programming languages also give you that ability to organize your code. I've observed, for myself at least, is that if you do programming enough, it will become routine. It feels complicated at the start, maybe, because you need to get it's a bit like the cycling. When you were 3, 4, 5 years old, you started to cycle, you would fall over quite a bit. But now, for me at least, it's natural, right? If you do it enough, it becomes natural. Programming becomes a routine kind of thing to do. And for me, also a fun thing to do. Next slide, please. And what is computational thinking? Well, computational thinking, in my mind, feels very much like the problem solving. So according to Wikipedia, it refers to the thought processes involved in formulating problems so their solutions can be represented as computational steps in algorithms, right? So it's really the ability to think in terms of algorithmic steps. That is certainly part of problem solving. But doing programming itself also trains you in computational thinking. So it's yet another way of training your computational thinking. But computational thinking is a bit more than just programming, because programming always is tied to a programming language of some kind. But in real life, we are running solutions to problems all the time, right? And not all of that involves programming. Next slide, please. So the example I came up with is this. This is part of my record collection in my garage. Think about it. This is a arbitrary. These are records you just got in, and they're not sorting. How would you go about sorting a vinyl collection of this size? If you don't want to spend up too much time on this, then it's really important that you think carefully. How can I best do this? Maybe doing it in a not so clever way might take you 10 weeks. If you do it maybe in a cleverer way, it might take you only 5 days, right? So this is the problem solving part, thinking, how do I approach this problem? What are the steps that I need to do to solve this problem? But I hope you can also see there's no programming involved here. That's the algorithm that tells me what is a clever way of sorting. And this is certainly something you will learn in our algorithms course in our program. Next slide, please. Now, what also happens when you start to program, it also trains your abstraction facilities. So if you look at sorting algorithms, for example, there's not a sorting algorithm for vinyl collections and a different sorting algorithm for numbers, or a different sorting algorithm for addresses. The algorithms are basically all the same, but they abstract away from what you are actually sorting. As it turns out, the only thing you need to know when you sort something is whether this one comes before something else. So whether ABBA comes before Zappa, whether the number 1 comes before the number 2. That's all you need to know. And then the sorting algorithm can deal with this, independent of whether you're sorting vinyl records, people's names, or numbers. And this is the course that you learn that in. Next slide, please. Another typical example where it's not clearly programming that we're looking at is modeling complaints at a tax office. So if you are working at a tax office, there are procedures legally defined procedures on how to deal with complaints for people saying, I'm paying too much income tax. And one of the things that makes this actually much less trivial than you might think is that it's very specific. It's very jargon-rich domain knowledge that you need, because everything is only about taxes, right? So it's not even so. Computer scientists tend to have to know about these domains to be able to implement solutions for them. In taxes and complaints procedures, you have to deal with lots of different timelines and exceptional events that might happen. I mean, even the laws can change during the handling of a complaint. And what does that mean, right? This is actually what business analysts do, to understand how a company, or in this case, a tax office, operates, and how to support it with a well-defined process, and how to support a well-defined process with software. Next slide, please. And this actually is an example of such a process, which is the process for electing the Nobel Prize. And it's actually not a program, although for me, it is a program. It's just not written as what you would ordinarily understand as a program. It's a list of boxes with arrows between them. This is actually in a visual format that we call a business process model. And this can then be turned into a program if you want to, but you can also use this picture directly to kind of explain, this is how we operate. And for me, a process that describes how you operate, or a program that you have written that can be run on the computer, are not that different. And that's what, so they all have in common the same kind of underlying conceptual structures. Next slide, please. So one of the things you will find out when you become a computer scientist is that because you are always trained to implement code, to think about exceptional behaviors and inefficiencies, that is something that you will find out that will happen to you too, I think, if you choose to do this program, is that because we are encoding problems, problem-solving solutions into programs, and programs are not very clever, right? If you run a process, maybe you work at the tax office and you run the process, then you can quickly adapt to exceptional situations. A program can typically not do that. So we always have to be very careful, and that's why we have to be very analytical to understand what are the inefficiencies, what are inappropriately covered edge cases, what are maybe loopholes that we've designed into this process before we implement it. Next slide, please. When you go up, and I talked about this before when I talked about software engineering, programming by itself is not enough if you want to go into industry. It's an important skill as a basis. But in the end, what a lot of people will be doing is to develop applications. And for that, you need to be able to program the same way as that when you want to write a book, you first need to learn how to write. Then programming is learning how to write. Building applications is writing a book. And if you actually want to build software systems of the scale of, say, a Facebook, it's comparable to kind of building a Wikipedia. And lots of other things will come into play, and we'll talk about these things that come into play in our software design and engineering course later on. Next slide, please. So a lot of people often have, when the first thing people ask, particularly parents, when they talk about their students coming to study with us, they say, what languages are you teaching? Well, there's so many languages out there. Industry says, of course, every company by itself will say, you need to teach the language that we use. But actually, most companies use more than one language. So should we teach all of them? And every company uses different languages. And we don't know, for anybody who does our program, what languages, what companies they will join, and what languages they will use. Now, the advantage is that many programming languages have lots of things in common. So teaching yourself one language, for example, Java, will already help you understand a different language like C# or Scala or Kotlin. Right? And that, I think, that is why we actually focus on the concepts that underlie Java, because when we focus on the concepts and not on the particular technology, it will be easier for you, I think, to change, to move on to a different language, because you understand the concepts and you see how those concepts actually arise in a different setting, in a different language. Next, please. Right. So we chose Java. There's a reason for it. It is a popular language. It's a mainstream language. It's reasonably accessible. What I mean with that, it's reasonably easy to learn. And it's available on all possible platforms. So that's also easy. And it's object-oriented, imperative, and typed. We also teach you SQL, but that is a query language as part of our database course. It's a very different styled language, which I think is nice because it's so different. And then finally, in our AI and data mining machine learning course, we will probably use Python. Next slide, please. So I already hinted at that if you have learned Java, actually, it's much easier already to learn a new language which is similar to it, like C#, like maybe Rust, like maybe C++. There are differences. Each language has its own particularities, I would say. But every time you move to a new language, you bring with you what you have learned. And because we focus on the concepts when we teach you that, I think you are very well geared to do that yourself without us helping you. Of course, moving to a new language will always involve effort, because you don't know the libraries of the other language, and you don't know the ecosystem. Maybe they use a different programming environment or IDE there. But we're not teaching you those. We teach you the underlying concepts. We will let you experiment and play with an actual technology, Java, Python, and SQL as part of the labs, right? But the focus is really on making sure that when you ever need to adapt to a new working situation, then you can adapt to that yourself. Next slide, please. Now, one thing, and this is a little bit maybe also to kind of make you understand how we view programming, is that when you go on the internet now, a lot of generative AI tools can actually already write programs for you. And a lot of people are going around saying, oh, wait a minute, I don't need to learn how to program anymore because Gen AI can do that for me. Why would I do that? Well, I think it's quite clear if you are into programming, you know that given a program and understanding what the program does is actually not as a rule, not as difficult as constructing the program from scratch. Right? And this is maybe also true. Reading a new foreign language is actually easier than having to speak that foreign language. That tends to be much more difficult. And I think that, and also that when you think about going back to the original discussion about the analytical skills and defining processes, is that what I expect of a computer scientist is that he has the skills to think in terms of problems solving solutions, right? And although that may not necessarily directly map to a programming language, programming trains you in that. Generative AI does not train you in that. So for me, Gen AI is like using a car to help you learn how to cycle. You can use the car to get where you can go with your bicycle, right? But it doesn't train you how to cycle, right? So that is why I think Gen AI is risky. Another associated problem is that generative AI can also hallucinate solutions. So it might suggest something that seems like a solution to you. But if you've never learned how to program, how are you sure? And remember that program bugs have killed people also before Gen AI, right? So in many situations, it's very important for us that we are absolutely sure that the program does what it's supposed to do. Not in all situations, but in many situations it does. Next slide, please. Okay, but that's what I had to say. It's a bit quick, but I hope it has kind of give you at least some feel of what being a computer scientist is about. And of course, I'm available here to take any questions. Thank you.
Thanks, Jurriaan. We have some pre-written questions. I think there are a couple in the chat as well, so we'll run through a couple of questions, and then if anyone would like to ask anything, once again, please do put them into the chat box, and we will answer what we can. So the first question is, the program welcomes students with diverse backgrounds. Could you elaborate on what level of prior computer science knowledge is expected, especially for those who may not have a BSc in computer science?
Actually, quite little, because the courses that you will be given, especially the first 4 courses, are what we call, they're fundamental, basic, in the sense that they underlie any computer science program that I'm aware of. Right? So we don't really assume that you know any programming, for example, because our first programming course will start from scratch. There's 2 reasons for that. First, because we want to be as open as possible to people with different backgrounds, but also because we often find that people who have some experience in, let's say, programming Python from the workplace, they're actually not that good at it because they never had formal training. They learn, but the only thing they learn is how people have done stuff on the internet. And that's not always, I think, the right way to do it. So we start from scratch. I think what will help you is if you have some idea of your abstraction facilities, and actually the math course will teach you that. It will learn you quite quickly, do I have those or not? Programming, according to many people, also depends a bit on abstract facilities. So a affinity with math or certain kinds of math will certainly help you, but nothing depends on that. And we certainly don't depend on any knowledge. No. Do you think that's good enough? Yep. Okay.
Yeah, that perfect answer. Thank you. Very concise. How does this MSc in computer science equip students with the industry relevant skills needed to excel in today's tech-driven world? And what specific career opportunities and pathways does the program open up for its graduates? I think we've covered some of this previously.
Yes, exactly. So when I was looking at your slides, I thought, okay, but you've kind of answered that already in your slides. So certainly software developer, software engineer, data scientists. I mean, certainly you can always do more. If you become a data scientist, it's not just about the coding. It's not just about the cleaning of the data. It's also, for example, about visualization. Well, there is no course on visualization here. So yes, there will be things missing that you might want to pick up in some other way. I think what is the strength of this program is that it kind of makes you hopefully a computer scientist in the basis, right? Somebody who thinks like a computer scientist, who looks at problems and solves them and thinks of solutions, how to implement them. And then later on, we focus on these 2 courses on AI and machine learning that are in very high demand everywhere, and give you a solid basis in those courses that is not just fashion and fad, right? But really based on things that we would normally teach our students, and where you also get practical experience by doing the labs associated with these courses. Yeah, so every course we teach should have labs where you do things with that material, because listening is fine, But if you've never done anything with the material, it's going to stay superficial. You need to work at it. You need to work with it. That's true for programming. And that's also true for many of the other things we'll be doing in this program. So I think that is, so you say, well, industry relevant skills. For me, the main skill that you get is the skill to train yourself in new things. Because we have kind of shown you in detailed way, this is how you work with databases. This is how you work with some databases. But then you can also easily adapt to working with another database because they have concepts in common, right? That's inescapable. And the same is true for programming languages. The same is true for using this library in Python for doing your machine learning, or maybe using a Scala library for the same kind of purpose. It will be slightly different, but the underlying concepts will always be the same. They're just different realizations, as it were. So I think that is what I think is important of this particular program. And we talked about this career opportunities and pathways, I think, in part of your slides.
Thank you. And can you tell us a little bit more about the Heriot-Watt MSc experience and what to expect from this course?
Yeah, so I think I said something about it already when I gave this list of what do we provide to you, and that's the learning materials, the labs, solutions to the labs, there is office hours and so forth. So I think the important thing is that we realize is that people that typically apply for a program like this, they need ultimate flexibility in terms of when do I work on it. It should not depend on you being available at a particular time of the day. We have people from across the world doing this program. Some people say, I have the first 6 weeks of the semester, I don't have any time, but I will catch up in the next 6 weeks. That should not be a problem, right? So it's ultimately flexible. It's also ultimately flexible in a way that you can start doing a program now, the course now, and then maybe work blows up in your face and you say, oh, no, the next 12 weeks, I really have to be at work and do a lot of stuff. And then maybe the next semester you come back and do more courses. So also in that sense, because we offer all our courses, we're building up into that, but at some point, all courses will be run in parallel every semester. And again, that gives you this ultimate flexibility. What do we provide? I think I discussed it before. So we have short videos to support our materials. There are lecture notes that should be detailed and precise. There are books for further study. And there are assessments that you can do formatively to train yourself, because I think that is important, that you train yourself, work with the material as much as you can. But that's still something that the students should be doing. We can help them, but it will take effort.
Thank you. And I think this is our last question. What advice would you give to prospective students who are considering applying for the program?
Do I have advice, really? Well, like I said, you have to work at it, right? I think you should. What I viewed when I started myself as a computer scientist, I mean, I loved it, right? I mean, I was coming out of secondary school, which I didn't like very much. I started doing computer science and I loved all of it. And I spent maybe not very, I mean, I didn't have a job, so that helps. I mean, but I spent evenings programming simply because I liked it. But that also made me a much better computer scientist, just working at it. So I think it is important for you to realize that it will take effort if you really want to make the most of the program. Right? Because in the end, in whatever way you succeed in getting a degree, but if you don't really have the experience, then it will still be useless for you in industry, right? Because in the industry, they will expect people who can deliver. So try to make the most when you do this program with us. Play with whatever we provide. Try to look beyond. We can advise you on all of that, but engage. That's, I think, my main advice is engage.
Wonderful. Thank you for all of those. We have, I think, about 2 questions in the box. If anyone does want to book in some time with an enrollment representative afterwards, please use this QR code. And any final questions, please do put them into the Q&A box. First question is, thank you for the presentation. Are there any on-site lectures or labs available to voluntarily attend?
Oh, You mean on campus?
I believe so. I think that would.
Okay. Well, actually, the thing is that the way that courses are developed and delivered between on campus and online is very different. So although we have used existing materials as the basis for deciding, okay, we think this is relevant for you, this is not so relevant for you, and so forth, we actually started from scratch. I mean, I need to look at whether we can make things available, but it's not the intention. We typically, for example, don't record any lectures for our on-campus students. They're supposed to come to class and attend them there. So in that sense, no. I think it would be easier to kind of, I mean, we can discuss, for example, if you say, look, Jur, I've done this program, this course, I'd like to have some more in-depth knowledge on this or that. Then, for example, I've done that before about the programming course. I can give you pointers to where you need to look. But I think it would be more on an ad hoc basis. Would be my suggestion. What I don't want, because it's always a bit risky, because I know that our courses are not the same as our on-campus courses, and this is intentional. And because I think you need different things. You need them at a different pace. You need them at maybe different. We've made certain choices on, for example, when we talk about algorithms. If you have a 4-year undergrad program, you may have multiple courses on algorithms potentially. And we've selected what we think are the important bits for your course in particular. So I guess it's possible, but I'm not necessarily whether it's natural to want to do that.
And the only other question I think is very similar, but someone's asked, can you use any of the university facilities like the Robotorium?
Well, the Robotorium is we have it here, and basically what it tells us is that people consider us, particularly, I mean, in the UK, consider us to be a hub for robotics. The robotics itself doesn't show in any of our courses. Clearly, I mean, if you do the AI machine learning course, large chunks of what would be useful for a roboticist would show up in that course, but we don't, for example, have a robotics course. And one of the main reasons is that, well, if you want to do stuff with robots, you need to be on the site to work with the robots. Again, I mean, if I look at the people that join this program, only very few of them live anywhere close to Edinburgh to be able to travel in. So I think maybe the case is different for you. We need to look at it. I mean, it's not that students, I mean, sometimes students do a project at the Robotorium, but actually they're not that common. The Robotorium is actually, for a big part, used for industry to come and do their experiments with our academics. And sometimes students are involved, but very much on an ad hoc basis.
Brilliant. That is all the questions we have. So I would just like to say thank you for your time today, and thank you for all of your wonderful insight in your presentation. And thank you for everyone for attending as well. The application deadline is the 4th of August, and classes will be starting on the 8th of September. So please do get your applications in, and hopefully we look forward to having you on the course.
Thank you very much for attending.